Hey there, you geometry cats. Today we're looking at 9.5, dilations. Okay, when you think of dilations, think about if you've ever been to the optometrist and they dilate your eyes, right? And when they dilate your eyes, you end up looking like a crazy cartoon character. Because what's happening is your pupil, that black part of your eye, gets bigger and crazier looking, okay? So that's a dilation. It is a dilation. Because dilations change the size of a figure. Okay? Key concept. Key concept. Yeah, it's a key. Dilation with center C and scale factor N has two properties. If N's bigger than 0, then what you do is you draw a line. You make it however much bigger you need to. Dilations make similar figures, but they're not congruent. So this is not an isometry. Okay? So for example, if n's greater than 0, right? If n was 2, if this distance was 1, this one would be 1, the whole thing would be 2. Okay? And if this side was 2, this side would be 4, right? You're timesing everything by 2. Okay? It's a scale change. Yep. Okay, what are the images of the vertices PZG with the dilation center 0, 0 and scale factor 1/2? I guess we need to know what PZG is. I'll just make it up. Let's say P is 2, 3. And Z is -1, -1. And we'll say G is let's go with 3, 0. Okay? So, we're changing the size of this beast, right? So P is at 2, 3, right? Z is at -1, -1. I'm making this really difficult myself. And G is 3, 0. Okay. Now we're using a scale factor of 1/2. I'm actually even going to zoom in. Where's my toolbox? Okay. So if my dilation center is at 0, I actually don't have to worry about those lines that were shooting off before. I can just take these points and cut them each in half. So P to P prime, well, that's going to be 2 over 2. This is going to be 3 over 2. Because I'm timesing them both by 1/2. Right? So that is 1.5. So P prime's at 1.5. Okay. G to G prime. So now I'm going to have 3 over 2 and 0 over 2. Because again, I'm timesing them both by 1/2. So 1.5, 0. Make this one blue too. So that's my G prime. G series. G prime, that gets you right? And then we'll go with the Z. We're going to times them both by 1/2. -1 times 1/2 is -1/2. -1 times 1/2 is -1/2. So you go -1/2, -1/2. That's my Z prime. So this will be my new triangle with a dilation of 1/2. That was my original. Okay. Where's my zoom button? Okay. Oh, look how tiny that writing is. It's so little. Okay, in problem 2, how can you prove that your new image is similar to your pre-image? Well, Ready for this? We'll just start it. You can say PZ over P prime Z prime is going to be congruent, not congruent, you just say equal, to ZG over Z prime G prime. And the reason why you can say that is, well, each one's going to be a half, right? Half the other one. Well, PZ over P prime Z prime, it's going to be 2, right? See about that would be a half. That's half the size of that one, right? 1 divided by half is 2. And that equals, well, it's 1 divided by half. 1 divided by half is 2. Okay. Don't overthink these ones, guys. If I give you the dilation is 3, you just times all your points by 3. If I say it's 5, you times everything by 5. If I say it's 1.35, you times everything by 1.35. Okay? Whoa, wrong button. That's my graph. Why did I use that graph paper? So you're looking at your computer. The height of the document on your screen is 20.4 centimeters. Okay? When you change the zoom settings from 100% to 25, the new emulation is a dilation, a scale factor 0.25. What's the height of new image? So you take your original height, and you times it by your scale factor. That's all there is to it. When you do that, you get what, 5.1? That's all there is to it, guys. This stuff's nice. Do you know they got this scale factor? 25% over 100. 0.25. It's on the last slide. Why is that there twice? Okay. The blue figure is a dilation of the black figure with center A. 2 students made errors. You need to explain correct their errors. Okay, how do we get from the little triangle to the big triangle? That's the question. Well, this person said, well, it's 2 over 6. Okay? Because it's getting the blue image is the blue is the image, so we got smaller. Now let's try that. What's 6 times a third? Yeah, that's 2. But what is the length of this side of the triangle, guys? Oh yeah, it's 8. Okay? So my big triangle is actually 8. So let's try again. What's 8 times a third? Not 2. So they thought that the side of the big triangle was 6. Well, it's actually 8. Now let's see what this Yahoo did. They said it was 4 over 1. Which is 4. Okay. Let's try it. You start with 8, times it by 4. It's 32. Small one's not 32. They flipped it around the wrong way because we're getting smaller, guys. If n is between 0 and 1, you're getting smaller, which we're doing. So it has to be between 0 and 1. Make sure you write this down somewhere. If n is greater than 1, you're getting bigger. If n is 1, nothing, you're staying the same. Okay? So to actually do this, you're going from 8 to 2, right? Right? So your scale factor is actually 2 over 8, or a fourth. Because what's 8 times a fourth? It's 2. And that's what we want to do. The end.